Hey guys, what's up? How are you all? Welcome guys. Welcome to Vedantu's JEE channel. How are you all? All those students who are moving from 10th standard to 11th standard, I welcome you all specially because this session, as always, is a part of series which is specifically is being done by Vedantu for students who are moving from 10th standard to 11th standard. Or in short, I can say that people who are targeting JEE 2022. So all those JEE 2022 aspirants, give me a shout out in the chat box. Okay. So guys, today we are going to start a new chapter altogether. The name of the chapter, as you can see, is a very fun chapter according to me, and one of the very fundamental as well, called as vector. Okay. So today we are going to talk about the very first part of vectors. Vector representation is what we are going to learn, and its types as well. Don't worry, there are a lot of things that I'm going to speak about today with respect to vectors. But then I know that a lot of you are here on the channel for the first time. Yep, how many of you are here for the first time on the channel? Tell me that as well. Okay, especially in the comment section if you are watching this video not as it is coming on the channel. If you are watching it later, put that in the comment section if you are here on the channel for the first time. Okay, so if you are on the channel for the first time, guys, then yes, definitely there are a lot of things that I want to tell you all. Okay, starting off with my introduction. So, guys, this is me, your Suri Sir, and more popularly, I'm known as Mogambo. Yes, why am I called Mogambo, guys? It's because when you will crack the examination of JEE, Mogambo kuch hoga. Yes, I will be. Okay. Now, you'll be very much interested in knowing who all are the teachers who are teaching you in this series and also the schedule on which days do we meet. Okay, so students, if you are moving from 10th to 11th standard, I want to tell you that every day 7 o'clock you have to be on this channel. Let me take you through the schedule, and before that let me introduce you to the very own your teachers. So guys, this amazing person is Love Sir, and he is your chemistry teacher, and this awesome person is Arvind sir. He is going to take care of mathematics for all of you guys. And yes, this poor fellow here is me. I will try to teach you physics. Okay, so this is your physics, chemistry, mathematics teachers and the entire team of Vedantu who's here for you to help you out. Okay, now as I said, every day 7 p.m. is very important for you because 7 p.m. every day we meet for the theory session. Okay, and also 8 p.m. is a very important time for all of you because on 8 p.m. we meet for MCQs. Now for today, yes, the timings and the slottings are different because of the yesterday's holiday, but then no problem. Usually this won't be the case, and every day remember on Monday and Friday I'm going to meet you, unlike today. Okay, and on Tuesday and Thursday you will meet Arvind sir for maths. Wednesday, Saturdays you will meet Love sir for chemistry. And for MCQs, as far as that is concerned, when are we going to discuss only the problems? That is Tuesday for physics, Friday for chemistry, okay, and Saturday for mathematics. I hope it's clear for everybody. All those who are moving from 10th to 11th standard. This is specifically for you guys. People who are moving from 11th to 12th standard, guys, don't worry. We have a separate session for you every day, 9 o'clock. We meet you there. Okay. Now, guys, if you are targeting for JEE 2022, not just YouTube sessions sometimes, are the one which could be helpful. We have during this lockdown entire Vedantu content free of cost available for you. In fact, the 2020 batch on Vedantu platform, for which the link is this, guys. By the way, you can follow this link. Go on the Play Store, download the app. You can follow this link, and you can enroll for free for the batch which is preparing for JEE 2022. Okay, so don't miss out on this, and definitely come for that batch. Okay, yes, definitely me, Love sir, and Arvind sir are also teaching in that batch, so don't worry. Okay, now guys, if you are on the channel for the first time, definitely I would want you to subscribe to the channel and also press that bell icon so that you are not missing out on anything that is happening on this channel, and you will be notified about everything. Okay, so guys, are you all ready? If you are ready, just give me a cheer, give me a shout out in your comment section in the chat box that if you are ready. Okay. So guys, very important chapter I'm going to start today. The name of the chapter is vectors. Okay, and today's part about vectors is vector representation and its types, and also we'll speak about something called as vector addition. So guys, I know that not a very new term for you when it comes to vectors. You guys first heard about this particular word in the class 9 standard. Okay, and I'm sure that you might still have a little idea about what exactly vector is. In fact, there is another term which is related to it, which is called as scalars. Yes or no? So guys, let's start off with the definition. A lot of things will be studied in this chapter. Let me tell you before I even start talking about the definitions here. One of the very fundamental chapter of physics. As I told, similar thing about calculus, new but very fundamental, and is going to go all the way till your 12th standard and beyond that when you will pursue your graduation as well. Okay, so vectors are going to be a lot helpful, especially the moment I'll tell you what exactly is a vector quantity, you will recall, and then I'll tell you why it is so important to learn this chapter. Okay, this chapter will also come in mathematics, but I'm telling you the way we use it in physics, nowhere close to that you will come to know in mathematics. Okay, for 2 years, vectors is going to be there. So guys, let's start here. What you see here, the first one is a definition which is written for all of you to guess. Have you guessed already? Yes, physical quantities which have only magnitude and no direction. What do we call them, guys? Yes, we call them scalar quantities. I hope you guys have heard about it. Physical quantities which have only magnitude and no direction are called scalar quantities. I'll come to the examples. Yeah, can you suggest me some examples? Yeah, very good, guys. Mass and say temperature. How about length? Yep. How about volume? Density? Speed? Distance? Work? Energy? Power? Pressure? Numerous. N number of such quantities, guys. N number of such quantities, and as and when in physics we'll learn about them, we'll every time try to understand whether a quantity is a scalar quantity or not. Okay. Now, what is important is that when you are measuring any of these quantities, be it mass, temperature, length, volume, anything, you only are concerned about their magnitude. You are not concerned about their direction. It doesn't make sense only. What is significant for quantities which are written over here right now is only their magnitude, right? Direction doesn't make sense when you speak about these things. Yes or no, guys? So if you say what is the length of this pen which I'm holding right now, say it is roughly 12 centimeters. In which direction? Nah, it doesn't make sense if you speak about its direction. Getting my point? Great. Now, when it comes to speaking about the other quantities, which are physical quantities which have both magnitude and direction, both are significant. Yes, my dear friends, they are called vectors. Very important. Let's talk about certain examples. So guys, if I speak about examples, you will have, say, the first example, I'm sure all of you know this, displacement, velocity, say acceleration, yeah, anything else? Very important quantity coming up, yes, force, then momentum, at least as many as you know so far, these are the quantities which I can say are the vector quantities. And in 11th and 12th standard physics, there will be a lot of quantities which I'll introduce you to, and then I'll tell you that they are vector quantities. But what is important, guys, is that not just magnitude for these quantities, but the direction is also important. Say, for example, if I ask you that there is a body and it is placed on a ground, and I'm going to apply two forces on this body. Both forces are of 10 Newton each. Okay. So what will be the acceleration of the body? what will be the acceleration of the body. And in detail, you don't need to know. You all need to know is that acceleration, if I want to calculate, acceleration is force upon mass. And say the mass of the body is 1 kg only. That means the value of acceleration is going to be equal to the force only. So can you tell me what exactly is going to be the value of acceleration? Hmm? Give it a thought. Give it a thought, guys. What do you think? What do you think? Mm, is it going to be 10 plus 10, 20 meter per second square? How many of you are saying that? Hmm? I can see some of you are saying 0 as well. Hmm. So let me tell you guys, this is what the vectors quantity create a confusion about. So if I say, if you have a top view of this body, top view, if you are looking at it from the top, if you apply both the forces like this, 10 and 10, then the net force acting on the body is how much? 20 Newton. So the acceleration also becomes 20 by 1, that is 20 meter per second square. But say if you have this body on which the forces are acting in this manner, then what is the net force acting on the body? It is 0 Newton, guys. Then what is the acceleration? Body is not going to even move, so no acceleration at all. And not just that, guys. How about I apply a force like this and I apply a force like this? 10 and 10. You will see that the body will effectively experience a force somewhere between 0 and 20. You will come to know after some time that this is the minimum value possible of the force acting on the body, and this is going to be the maximum value of the force which is acting on the body. So, did I change the magnitude of the two forces in this example? No, I did not. Yeah, I did not change the magnitude of the force acting on the bodies here. But what eventually changed here is basically the direction in which the forces were acting, and they resulted in totally different situation. So such is the importance of direction for the quantities which we call as vectors. Please keep the understanding very clear. These are the quantities for which only speaking about their magnitude will never make complete sense. It will make complete sense when you are also aware about their direction. Okay, awesome. And my dear friends, that is why the entire chapter is going to revolve around only vectors. It's not going to revolve around scalars, because scalars are something which you have been dealing throughout your life so far. Till 10th standard, whatever you have studied in science, you have been dealing with scalar quantities. In fact, with vectors also, you have only spoken about their magnitude. Now, when we are going to learn about vectors, broadly, I'll divide the entire chapter into not three, but two categories. First, we'll try to understand how do we represent the vectors so that we can communicate about the vectors. And second, we are going to speak about how to do mathematical operations with vectors as we could do with scalars. Scalars, we add, we subtract, we multiply. Same way we want to add, subtract, multiply the vector quantities as well. Okay, so let's go ahead. Let's start off with the first part of the understanding of vectors, and that is representation of the vector quantities. So guys, I'll be basically telling you three types of representation. The very first one is basically the symbolic representation. How a quantity with symbol A will be having vector representation. So what you see here is basically the vector representation of that quantity. Yep. So what you see here, if the quantity is usually represented by a symbol A, then writing A with the arrow like this is basically what you call as the vector representation. For example, say if you represent displacement with S, then writing S with a arrow over it in the right direction is only how you represent the displacement vector. Similarly, velocity vector, acceleration vector, force vector, and momentum vector. Okay guys, no other direction of arrow you will mention, only arrow which is pointing towards right side, because it is a symbolic representation. It's not telling you anything else, it's only a symbol. Okay, apart from that, what you see here, if you put vector symbol the vector symbol, if you put it in modulus, then this will basically represent the magnitude of the vector. Or there is another way also. If you, instead of putting it in the modulus, guys, if you just write the alphabet, also, that means if you just write A, this also means the only magnitude part of the vector quantity. Like if I have to talk about the magnitude of displacement, I'll just say S. If I have to talk about velocity, I'll say V. Acceleration magnitude, force magnitude, or momentum. Sorry, that is vector. Only the momentum vector. Its magnitude. Yep. You can put the symbols in modulus also. That will also be representing the magnitude. Okay guys, that's simple symbolic representation. Now let's try to understand how do we represent vector diagrammatically. So diagrammatically, this is how you are going to see a vector quantity being represented with a line, a straight line with an arrowhead over it. Okay, but here things will be little advanced. The length of the line, by the way, will represent the magnitude of the vector quantity. Okay, so if what you see here is a length of the line, if you are able to have a comparison here with another vector, the length of the line will give you an idea of the vector quantities magnitude, and obviously the arrow will tell you the direction. Like if I would ask you guys, say if this is representing a velocity vector, say this is velocity of magnitude 10 meter per second towards east. Okay, say this is towards east, then can I say that a velocity which will be, say this is v1, so a velocity v2 whose magnitude will be 20 meter per second towards east, the length you can see clearly has almost the double value. So the length of the arrow, that length of the line that you are looking at, that is giving you an idea of the magnitude of the vector. V1 vector has smaller length, V2 vector has bigger length. That's is basically the whole idea of diagrammatic representation. Okay guys. So basically in diagrammatic representation, the vector could be in any possible direction depending upon how the quantity is in existence happening. You can think in terms of displacement. So bodies can be displaced in any possible direction. So that's why you can see I'm drawing vectors in any possible direction with any possible magnitude and in any possible direction. Okay, awesome. Now on the basis of diagrammatic representation, we'll try to categorize vectors into 5 basic categories. Let me take you through them. The very first one will be called as the like vectors. As the name suggests, no, nothing to do with Facebook. Okay, like vectors are basically the vectors which may have different magnitude, but they definitely have same direction. Okay, so vectors having same direction are called as like vectors. As you can see, these three vectors are pointing towards the same direction. Okay, but they don't have the same magnitude. Okay, guys. If I have to give you an example, guys, two cars which are moving towards east but don't have same speed, so their directions will be same, but they will not have the same speed. So their velocity vectors, speed is a scalar quantity, so their velocity vectors will be like vectors. Okay. Same thing if I speak about next type of vector called as equal vectors. Now these are basically a specialized case of like vectors, you can say. Vectors which will have equal magnitude and the same directions as well. Those vectors will be called as equal vectors. Like if I have to say that all the trains which go from Delhi to Bombay, all the trains which go from Delhi to Bombay, they all move in the same direction and they all cover the same amount of displacement also. So their displacement vectors are basically equal vectors. Okay. Now comes negative or opposite vector. They are also called as negative or opposite vector. So vectors which have same magnitude, very important, vectors which have same magnitude but just opposite direction. Okay, guys, one thing also I forgot to mention here. Say if you have this vector as A and this vector as B, so in equal vectors, vector A and B can be written just like this because they have equal magnitude and same direction as well. But when we are speaking about negative or opposite vectors, okay, here if I say that this vector is A and this vector is B, we are saying that vector A is basically equal to minus of vector B, or we can say vector B is equal to minus of vector A because they are just equal in magnitude and opposite in direction. So that minus sign is giving you the indication of their direction. So magnitude wise, I can say that A will be equal to B. So you can see that A vector equal to minus of B vector, but A is equal to B in terms of magnitude. Like all the trains which are going from Delhi to Bombay and the trains which are going from Bombay to Delhi, they are covering the same amount of distance, but they are covering it in the opposite direction. So their displacement vectors are basically opposite vectors or negative vectors. Okay. Now next comes a zero vector. Now what exactly is a zero vector? As the name suggests, any vector which have no magnitude, zero magnitude, and has insignificant direction. Obviously if there is no magnitude, direction doesn't make sense. Okay, so such vector will be called as zero vector. Now think about think about a zero vector. So a train starts from, say, Delhi, comes to Bombay, and then from Bombay goes back to Delhi. Okay, what is the net displacement of that train? Zero. So the displacement vector of such train will be called as zero vector of displacement. Similarly, an object which is at rest, what is the velocity of that object? Zero. So its velocity vector is a zero vector. Okay, I hope you guys are enjoying so far. Now, guys, the most important vector is now coming on your way. The fifth and the last one, I would say the most important one, called as the unit vector. Yes, as the name suggests, unit basically means one. Okay, so as the name suggests, a vector whose magnitude is one and has any possible direction is basically what we call as a unit vector. Now, what you see here is basically vector A. Okay, and we want to talk about a unit vector. So first of all, unit vector will have a specific symbol. So if I am interested in talking about unit vector along A, then it will be A with a cap over it. This is what we pronounce it, A cap. Okay, so this power sign that you see over here is basically cap. So if I say that, if you see that this is vector A, and if I divide vector A into all equal portions which have magnitude 1, okay, so if you see these are all equal in magnitude and in the same direction. So all of them, if they have magnitude 1 unit, if they have magnitude 1 unit, then they are all unit vector along the direction of vector A. So how do I find out the unit vector along direction of vector A? Very simple. Divide the vector by its own magnitude. As if I have to give you an example, say there is a velocity 10 meter per second in east direction. So what is unit vector of this velocity? It is 1 meter per second in east direction. Yes or no? Are you getting it, guys? Yep. Because 10 meter per second has 10 unit vectors involved in it in order to make a single vector. So each unit vector has magnitude 1. Every unit vector will have magnitude 1 of any quantity. It could be a unit vector of displacement, of velocity, or of acceleration, force, momentum, or any quantity that we are going to come across. Please remember, any vector divided by its own magnitude will basically result in a unit vector. Okay, I hope it's clear to all of you. Okay, guys. Now, why unit vectors are very important is the part that I want to explain you all. So what we are going to do basically, so far, if I speak about, I haven't, but if I speak about directions, guys, we usually think of directions as east, west, north or south, or maybe up and down, right? So these are basically the 6 possible directions that we think of in general. Let's try to represent them with the help of x, y and z axis. So east is x-axis, positive x, west is minus x-axis, say north is y-axis and south is minus y-axis, coming out is z-axis, going in is negative z-axis. So what we are going to do, guys, now, the whole idea of defining unit vector is to assign 3 unit vectors specifically to x, y and z axis, which will now represent their direction. As you can see here, what I'm doing here, I'm assigning I cap vector to x axis, j cap vector to y axis, and k cap unit vector to z axis, which simply means what? If I will be speaking about negative x axis, I'll basically be talking about direction as minus I cap. Similarly, negative y axis will be minus j cap, and negative z axis will be minus k cap. So these are the possible 6 standard directions for the 3-dimensional world that we live in. Are you getting it, guys? Now, how does it help me? Is, let me try to explain it to you. What you see here are a few vectors that I have tried to represent mathematically. So if I say that this is my vector A, then this vector A is represented as 5 I cap. If you will look at its diagrammatic representation, everyone, please pay attention. Its magnitude is 5. You can see that 1, 2, 3, 4 and 5 is the magnitude of this vector, and the direction is parallel to x-axis. And x-axis now has I cap unit vector representing its direction. Always and always, I cap means x-axis now, j cap means y-axis now, and z axis will be k cap. So the way we were so far talking about the direction was 5, say this is velocity is 5 meter per second towards east. Now I will never speak about directions as east, west, north, south. Rather, I'll speak about the directions in a mathematical sense. That is what we have done by providing unit vectors to x, y, and z axis. We have given direction, which is an abstract concept. We have given it a mathematical sense. Getting my point, guys? What happens here if I multiply 5 with a unit vector? The magnitude does not change, but a direction gets added to it. Are you getting it, guys? So now when I tell you that this vector is 2 I cap, so just close your eyes, think about it. Its magnitude is going to be 2, its direction is going to be I cap, which is basically along x-axis. That is the information that you always want from a vector quantity. A vector quantity is basically a quantity which has magnitude as well as direction, and I am able to represent it with the help of mathematical possibilities. Okay. If I speak about minus 8 I cap, so what does it mean? Minus 8 magnitude and I cap direction. What do you think, guys? If I tell a vector is minus 8 I cap, does it have a magnitude of minus 8 and direction as I cap? So look at the diagrammatic representation. Yep, this vector is basically 8 minus I cap. Always remember that magnitude will never be negative. It's 8 only, which is the magnitude, and minus I cap is the direction. So the vector has magnitude 8 and the direction is negative x-axis. Okay, and say this one 2 k cap, magnitude is 2 and direction is z-axis. Okay, so when we try to represent a vector in the most general form possible, this is how we try to represent a vector in most general form. Okay, which is ax I cap plus ay j cap plus az k cap. What do we understand by ax, ay, az? They are basically your components of vector a along x, y, and z axis. If I have to tell you very simply, if this is your vector a, this is basically the shadow of vector a on x, y, and z axis. Okay? If this is your vector a, then ax, ay, and az is going to be the shadow of the vector on x, y, and z axis. Remember that, shadow. Okay, that's what we will be calling as components technically. And if I have to find out the magnitude of this vector, so this vector will have a magnitude of ax square plus ay square plus az square. Okay, guys, derivation is really not important. Remember the magnitude as ax square plus ay square plus az square in under root. Okay, guys, so what is represented here is a full-fledged 3D vector. If it will be a 2D vector, one of the component will be missing. If it will be a 1D vector, two components will be missing at the time. Okay, awesome, very good, guys. Now this was so far the representation part of the vectors. Okay, remember we spoke about the symbolic representation, we spoke about diagrammatic representation, and now we have spoken about the mathematical representations as well. Now comes the part where we do the mathematical operations with vector. And the very first mathematical operation that we want to do with vectors is basically the addition of vectors. And now in the beginning, I'll basically start trying to add two vectors at a time. Only two vectors at a time, and I'm trying to add them. And what do we call that? The first method of adding two vectors is what we understand as the triangle law of vector addition. Okay, you must be thinking, what exactly is a triangle law of vector addition? And in the diagram right now, there is no triangle at all. All I see is basically two vectors diagrammatically represented. They seem to have different magnitude, they seem to have different direction. And that is the beauty of triangle law of vector addition eventually. Okay, you will have vectors which are randomly placed in the space around you, and you will still be able to use them to find out what? To find out their resultant. This word is going to be very, very, very commonly surround you now from now onwards whenever you will be dealing with any vector quantity. Okay, so if I have to tell you what exactly vector addition physically or logically or understanding point of view it means that whenever you are going to add two vectors or any number of vectors for that matter, you basically want to replace all those vectors by a single vector which will do the same job as it is done by those vectors which were added. Okay, I'll give you the practical example also, but let me first tell you how the triangle law is formed. So say if you have these two vectors A and B, you have to arrange them in a very particular manner. What is that manner? Say you pick your vector A here. Okay, you have not done nothing, you have just displaced it and put it somewhere else without changing their magnitude and direction. You can see that they are still the same vector, vector A. Now look at the way I am placing vector B. Okay, guys, I hope you are able to see this. Vector B is being placed on vector A in such a way that head of vector A and tail of vector B are lying at the same point. Okay, that's a very crucial point here. Head of one of the vector and tail of the other vector, anyone, but they have to be at the common point with one of the vectors head, one of the vectors tail. Okay, now if you join the remaining tail to the remaining head in this way, this is what basically represents their resultant. So our vector is basically the resultant of A and B. This is what I'm trying to tell you here. Now what do I mean by this? Let me give you a practical example, guys. See, try to visualize, say you are moving as a person from point O to P. You're moving, okay? That means you're displacing. So say you displaced yourself from point O to P, you walked on a road, okay? Then the way changed the direction. So you also changed your direction and you started walking in this direction, okay? And finally you stopped here, okay? Say at point Q. So if I ask you, what is your net displacement? What is your net displacement, guys? Yes, you know this, the shortest path between O and Q, and that is this. This is your effective displacement. Now, think of applying this for any vector quantity, be it to velocities, to forces, to accelerations, to momentum. Later on, we'll speak about, say, electric field, gravitational field, any vector quantity, any two vector quantities, if are arranged in this manner that a triangle is formed, then vector A and B's resultant is vector R, which is replacing both vector A and B, doing the same job as it was done by vector A and vector B. Okay, I hope it is clear. But let me make it even more clearer by giving you a mathematical example here. So say guys, you have vector A as 2 I cap minus 3 j cap plus 5 k cap. Okay, so that's basically ax I cap plus ay j cap plus az k cap, and all of them are individually are 1D vectors. Say vector B is, say, I cap plus 5 j cap plus say, let's make it minus 2 k cap. Okay, so what do we see here? We want to basically find out the resultant of all of them. So if I want to find the resultant R, which is basically A plus B, so when you are adding, always remember you are going to add only I caps with I caps, J cap with J cap, and K cap with K cap. So 2 I cap plus I cap is going to become 3 I cap. 5 j cap minus 3 j cap is going to be plus 2 j cap, and 5 minus 2 is going to be plus 3 k cap, a very randomly chosen example. Okay, if you want, you can find out the magnitude of this vector also as ax square plus ay square plus az square. Remember, or rather let's call it rx, ry and rz. So under root of rx square plus ry square plus rz square, which is 9 plus 9, that is 18, 18 plus 4 is 22. So under root of 22 is basically the magnitude of your resultant vector of vector A and B. Okay, now I'm giving you a idea of the situation how we are going to add if there are more than two vectors involved. This was only two vectors being replaced. These two vectors could be seen as force, displacement, velocity, acceleration, as I'm saying again and again. What if there are more than two vectors involved? So what we are going to see, earlier a triangle was formed. Now what you'll be dealing with will be called as a polygon law of vector addition. As you can visualize it now, it's basically an extension of triangle law. Say you are having these multiple vectors over here. You see that? A, B, C, D are the four vectors randomly placed. And now you start arranging them strategically as A vector. Then you will put vector B in such a way that vector A head and vector B tail lie at the same point. Okay, followed by vector B's head and vector C's tail at the same point is going to happen. Okay, before that, this is what the triangle law told us. But now what I'm going to do, what you see here is vector C, right, on the head of vector B. Now you can actually find out the resultant of, say, this vector, which is R1, and R1 vector's head and vector C's tail are also at the same point. So this is their resultant. Okay, what was R1? R1 was basically A plus B. Yes or no? And this vector is, say, R2, and R2 is basically R1 plus C vector. Yes or no? This is R1 and this is C. So this is R2, which is R1 plus C. And now I'll draw vector D, and you can see now, focus only on R2 and vector D. Their resultant is vector R. And what is vector R, guys? Vector R, you can see, is nothing but R2 vector plus D. But what is R2 vector? R2 is R1 vector plus C plus D is already there. And what is vector R1? Vector R1 is vector A plus B. Then you already have C plus D. Yes or no, guys? So what you are getting here, everyone, what you are getting here is basically the resultant of vector A, B, C. I'm sorry, this is vector D and vector D. Okay, means all you have to do, if you remember the previous example, guys, if you remember the previous example, this one, what did I do? I added I caps together, j caps together, and k caps together. The same thing has to be done here when you are adding multiple vectors. All you have to do is arrange the vectors in such a way, all you have to do, guys, you have to arrange the vector in such a way that head of first vector and the tail of the next vector consecutively or successively, you have to place them in the same order. Finally, you will have a vacancy of a tail and a head. Join that remaining tail to the head. That is your resultant vector. And how about taking an example of, again, a multiple vector situation here. So say you have vector A, which is I cap minus j cap plus k cap. Similarly, say vector B is 2I cap plus 2j cap minus 5k cap. Very randomly choosing any example. Say vector C is minus 5I cap plus j cap plus 2k cap, and vector D is, say, 3I cap minus 5j cap and plus 2k cap. Okay, so if I'm interested in finding resultant vector R, I'm going to add all the x, y, and z components respectively. So you can see that this is 3 plus 2 5, 5 plus 1 6, 6 minus 5 is going to be I cap. Okay, next is 5 plus 2 is 7, and plus and minus j cap cancel. So I have, sorry, minus 5 plus 2 it is, which is going to become minus 3 j cap. Okay, and here I have 2 plus 2 plus 1, 5, 5 minus 5 is 0. So this is 0 k cap, or simply I can say vector R is I cap minus 3j cap. This is what my final vector is. I can find out its magnitude also as under root of 1 square, because this is 1 I cap, okay, and plus 3 square, not minus 3, okay. As I told you, there is no negative possibility of a magnitude. So what do I get? 9 plus 1, this is under root of 10. Are you getting it, guys? If these four are the forces here, if these four are the forces here, then the force that you have got is I cap minus 3j cap, which will replace all these four forces and will do the same job, will make the body accelerate with the same acceleration as was done by all these forces put together. Okay, I hope you guys enjoyed this session so far, and we have actually learned a quite great deal about vectors today. Okay, so guys, this brings us to the end of this session. Hmm? So if you are interested in getting more things related to your own studies, you know that you can help, or rather you can get the help with the help of Vedantu's Telegram group as well. Okay, not just the YouTube channel is enough. You can get more assignments, as you can see here, more study material and daily updates on our Telegram group. All you have to do is follow this link. This link is available in the description of this video as well. Okay, all you have to do is click there, come to the Telegram group. You will not miss out on any of the things. Okay, So guys, if you enjoyed this session, if you really understood vectors, do hit that like button. Okay, do tell your friends, share them this video, and yes, do subscribe to the video. Do subscribe to the channel, and more importantly, press this bell icon. Why? Because you want to be notified with everything which is happening over here. Okay, guys. So this is the very first session comes to an end. All those people who could not watch it when it is coming on the channel, watch it later on. But do tell me your comments. How did you find the session? And I'll meet you again with session 2, where we'll continue with mathematical operations with vectors. Okay. Till then, keep studying, keep enjoying physics. I'll see you soon. Take care, guys. Bye bye.